Hello everyone. Myself Dipti Gusse as Assistant Professor in School of Computer Engineering at Apandi Academy of Engineering, Alandi, Pune. Today's topic on demonstration of implementation of pre-trained model for a classification of images using Imagenet weight. Now, in previous recording already we have discussed the basic architecture of CNN model, how we are using CNN model for the binary class classification and for multi-class classification. Kindly before watching this video, kindly go through the previous videos. Now let us discuss on how we are implementing pre-trained model. Now for the demonstration purpose, we have selected ResNet model, ResNet 50 pre-trained model. This is the pre-trained model, and 50 means there are various versions of pre-trained ResNet model. Now in this example, we are utilizing ResNet 50, which consists of 50 number of layers in the pre-trained model. Now here, whenever we are importing, now here in this cell, we have imported the libraries required for the implementation. Now here we are importing this library. Now tensorflow.keras application.resnet, importing the resnet library for the utilizing the functionality of the ResNet. Also here we are importing the pre-process input and decode prediction which are defined in ResNet, which is used for the pre-processing and displaying the prediction result. Next, here we are importing this library. We are after importing all required libraries. Now here model.resnet. Now here we are creating the model using pre-trained model. Now whenever we are using any pre-trained model, at that time we need to set some parameter. Now here parameter we have set the weight is equal to Imagenet, as this Imagenet data set consists of 1.2 billion images, and these images are pre-trained, are successfully classified and recognized by this ResNet model. So here we are consider the weight is equal to Imagenet. Now all weight and weight value and features are stored for the Imagenet data set. Next parameter, that is the include top is equal to true. Now as already in transfer learning we already discussed, we are removing the last top layer in CNN model, and only we are freezing that features of the images. Whenever include top is equal to true means that we are adding we are only holding the features of the images, and top layer classifier layer we are removing. Now input image is given. Now this code is for only demonstration of how we are predicting the unseen images for the pre-trained ResNet model. Now once this model is ready, now using this model you can predict the class of the image. Now this c2.jpg which consists of the images, that is image of cat. Now this is the unseen data, we are checking the result, we are recognizing this image over Imagenet data set. That Imagenet data set already pre-trained trained using ResNet 50 model. Now here we need to load this image. Now after loading this image, during the loading you need to give the path and the target size of the images. 224 by 224, this should be the image data set size in images stored in a Imagenet. Now here, now we are plotting this image to display purpose. We are to show this visualize this output. We are using matplotlib. We are displaying the image. Next, then image is input image c2.image. It will be converted into array, transform into the array, that is the array of pixel. Now you can also display the shape of the image. You can also expand the dimension of the image as and it should be matched with your ResNet architecture. So here we are expanding the dimension of the image. Then before dimension expanding, and after expanding dimension you can display the output. Then perform the pre-process. In pre-process function, this is already predefined function by ResNet. Now we are giving the input image for pre-processing purpose, and then at the end we are predicting the output for the unseen image. Now for the selected model. Now this model which consists of which is which hold the weight of the images, and removing the top layer, and then dot predict, and then you can also display the shape of predict. Once after the completion of the predict, you can display the probability as this CNN model. This is the this ResNet model is pre-trained model, and here this image there are in Imagenet dataset there are total 1000 classes. Now whenever you are displaying the prediction, it will give the prediction of input image over 1000 classes. In this example only we are decoding the prediction of the image for the top 10 probability. Now whenever this we are executing this predict, now softmax will calculate the probability for 1000 classes, where the addition of all probability it should be 1, and here in this example only we are displaying top 10 highest probability. Now here this is the input image. Now here you can see before expanding the dimension of the image, now this is the size of image. This is the input image. Size of input image is 224 by 224, 3. Now here this image, whenever we are giving the target size after during the upload, now the suppose input size of input image is suppose 256 by 220 by 220. Now this image will be reshaped to 224 by 224, and this is the color image, so there are 3 channels. Now after expanding the dimension of the image, now you need to set. Now whenever we are giving the input to the ResNet architecture, at that time the input should be in 4 dimension. That is the first, that is the number of images, how many images we are passing in testing. Next, the size, height and width of the image, and the number of channels. So here we are reshaped this image to 4 dimension. Then after prediction, now this will be the, you will get the output here 1,1000 means that there are total 1000 classes are there, and it will display the output in this way, where the output is displayed with the probability. This is the class label code in Imagenet. This is the name of the class, and this is the probability for that given input. The highest probability for the given input for this image is 0.45, means the image belongs to Egyptian cat. This cat image belongs to Egyptian cat. In Imagenet dataset also the type of cat, type of elephant, type of lion are also are available. Now you can predict the type of the cat over the Imagenet dataset. Here in the code, actually the probability for 1000 classes are calculated, but here in this example only we are displaying only top 10 highest probability classes. Okay, tiger cat, these are the different. Now here as you can see the cartoon tiger cat, the value of probability is very less. So here we can conclude that is the predicted image with higher probability 0.45, that image belongs to Egyptian cat. Now this is all about how we are using transfer learning concept using pre-trained model to classify the unseen image over the Imagenet dataset.